is you can actually recover a graph from its graphical sequence, right? So I know from the previous example that the last sequence is graphical. I would like to recover it, okay? So let me actually, rather than describe the algorithm, I'll show you the example. You can read the algorithm. So here's the example. So I'm gonna actually go through the reduction using the equivalence of Habab and Hakimi. So again, you start with 5, 3, 2, 2, 5, 3, 3, 2, 2, 1, and so on down to 0, 0, 0. Remember, we ended up with N3 at the bottom. So that N3 I'm gonna call G1. And then I'm gonna work my way back. Each time I add a, remember, earlier we were erasing one of the degree values. Now we're gonna add, going from the bottom up, we're gonna add, so each degree corresponds to another vertex, right? So going from G1 to G2 means I'm gonna add one more vertex. And I look at the sequence that I have, it's 1, 1, 0, 0. So that means here are the 0. Give me a second, guys. Went too fast. So I'm gonna put the labels next to these. So these are the vertices with the corresponding degrees. So these are the vertices with 0, 0 degrees and 1 degrees. I should probably emphasize this. Now I'm gonna go up one level. That means what? I'm gonna add another vertex, right? Another vertex, so that's the one I'm gonna add here. So I'll put it right there. So what do I know about this one? Well, that one is gonna become a 2. And that one is 1, so this one, it's a 2. So it needs to be connected, so I'm gonna just connect it to those 2. And I'm gonna go up one more level. So that means I need a vertex that has a degree 5. And that's exactly what I'm gonna do. I'm gonna put a vertex here and connect it to the appropriate places where I get exactly degree 5. Okay. So G4 is, so after 4 steps, you recover your graph here from this forward sequence of reductions, okay? Now, the algorithms that I just described to you, they give you one example of a graph that has a given graphical sequence. It does not give you uniqueness, right? In fact, give me a second, let me go to the, in fact, I have here an example of 2 graphs with the same graphical sequence, and they are not isomorphic. But to prove that these guys are isomorphic, you have to kind of work at it, and that's stuff we're gonna do next time. So this one I can see, yeah. So again, I'm putting the labels that you see here correspond to the vertices and their degrees, right? So the 1, 1 means those vertices have degree 1, so that means only one edge, right? The ones with degree 3 that have 3 edges, and the ones with degree 2 that have 2 edges. That's the same for both of these pictures, right? For both of these graphs.